The main obstacle keeping solar panels from being widely used is cost, so we must address that. Even though current panels are becoming more affordable, many people still cannot afford them. What if I said we could create solar panels that were 3 times smaller, 3 times lighter, and 3 times less expensive than current conventional solar panels? I can see that everyone has their jaws open waiting to hear more. Without any delay, let's delve into our topic. Welcome back to another video of Theory of Science. Before the latest technology hits you with the cheapest solar panel, subscribe to our channel. Because of its stability, non-toxicity, and ubiquity, silicon is the material of choice in the electronics sector. However, silicon is a weak light absorber. In an effort to reduce costs, researchers have switched from employing pricey thick silicon wafers to less expensive thin film cells, which contain less silicon. As opposed to the 25% efficiency of larger, more expensive silicon wafers, this 1 to 2 micron thick film only converts 8 to 10% of incoming sunlight into power. Researchers are experimenting with novel strategies to increase the film technology's effectiveness while lowering prices. ARC Photovoltaic Center of Excellence researchers at the University of New South Wales, under the direction of PhD candidate Supriya Pi, have now demonstrated a 16-fold improvement in light absorptions in 1.25 micron thin film cells for light with a wavelength of 1050 nanometers. Additionally, they demonstrated a 7-fold improvement in light absorption at 1200 nanometer light wavelengths, which are used in more expensive wafer-type cells. According to Dr. Kylie Catchpole, co-author of Most Thin Solar Cells are between 8 and 10% efficient, but the new technology could raise efficiency to between 13 and 15%. They must think in a way no one else does, right? If they're below 10% efficient, then you really can't afford to put them, because it would take up too much of your roof space, for example, to power your house. That's a significant advancement. The technology becomes economically viable once its efficiency reaches 15%. A typical home might have satisfied all its daily energy needs by putting up a solar system with panels that cover 10 square meters of space. This method would not provide electricity for heating the water or cooking. The discovery, which will be detailed in a future issue of the Journal of Applied Physics, could potentially lead to a sharp increase in solar power's market share. Out of the 8 million Australian residences, barely 30,000 have solar panels at the moment. Let's look at a typical panel with the 2-meter surface area. Yes, size matters in this case, but we'll explain why in a moment. Let's say this panel puts out 330 watts when operating at between 50 and 20% efficiency. If it receives 8 hours of sunlight each day, it will produce about 2.8 kilowatt hours. A printed panel with the same size operating at 3% efficiency and receiving the same amount of sunlight would produce only a few. Printed panels are only anticipated to last 1 to 2 years, but conventional panels can currently survive over 30 years. Case closed, right? Why bother if they don't last as long and don't provide anywhere near the same quantity of energy? Since printed solar cells cannot compete with conventional panels in terms of efficiency, it is now time to think like an engineer. According to the Solar Energies Industries Association, the national average price of a domestic solar panel system is now estimated to be between 2.66 and 2.94 cents per watt. Take San Diego as an example. Installing a smaller solar system might cost a typical homeowner closer to $3 per watt. A single 2 square meter panel providing 330 watts at $3 per watt would cost approximately $990 or $495 per square meter. A 2.8 kilowatt system with 8 of these 330 watt panels could cost about $8,400 before tax incentives. Currently, manufacturers can create panels for less than $10 per square meters, which translates to 2 meters square. 10 to 15 watt panel costing about $20 or just 75 cents per watt. Of course, this is problematic since you would need 10 to 15 times the surface area to produce the same amount of energy. In that case, how would that appear? The cost of the project as a whole was about $2,000, and the pilot system used about 640 meters of printed solar panels in total, connecting to form a 200 square meter bank. At this scale, the technology could truly compete because the cost per watt is still much lower than it will be in the future. As we said at the outset, in an emergency situation, if there was a tornado or hurricane and there are large towns without electricity, this may make perfect sense. You may wonder who is going to think about this panel rather than worrying about their lives. It's right, but what if we survive? We have to live, right? Imagine being able to deploy them on roofs or even the ground to generate energy when you need it, especially if there are people in homes who require electricity for things like medical equipment. Although it might be extremely life-saving technology, the lifespan is simply too short for any practical commercial use at this time. That's all for today. Maybe one individual may consider switching to this type of energy source, I hope. Don't forget to subscribe to our channel and like this video if you enjoyed it. Remember to click the bell button if you want to see more bizarre videos like this one. Also, check out our other videos on our YouTube channel.